Good evening, everyone. I am very happy to introduce Sridhar. Sridhar is like a young brother to me, and there are very few people that I have found who have very, I mean, too much. I mean, great clarity on the subjects related to technology, and he currently he is running his own company, which is a deep tech company, Spotflock, and so that is headquartered at Hyderabad and with its offices in the US and Dubai as well. And so he is BITS Pilani and UT Austin alumnus, and he has been associated with Meta, which is the company behind Facebook, and other companies. And he is also a mentor to a lot of startup companies. And recently, one of his books has come out on AI, which I strongly recommend. It's a beautiful book, very small book. I mean, under 150 pages, I guess, and very lucidly written. I mean, I can say it is like AI for dummies sort of thing. It covers almost every topic, and it is so lucidly and simply explained that it is mind blowing. So I recommend it. Is available on Amazon. So I think with this, I won't. I mean, the name of that book is Uncommon Man's Artificial Intelligence. Sorry, I was missing on that. Uncommon Man's Artificial Intelligence, AI for Everyone. So with this, I will request Sridhar to take the podium and talk about his journey, and also take us to that journey of AI, what is latest happening in this field. Along with that, I had also requested him to touch upon all those questions around AI, like moral, ethical, social, political, economic questions also around AI. So Sridhar, generally the format is we have the speaker speaking for almost 45 minutes, and then the forum is open for any questions and discussion and so on. So with this, Sridhar, over to you.
Thanks a lot, everyone, for taking out time. I will try to do justice. I mean, that's the thing. Like, while you come from background where you know nothing about AI, if you have exposure to it, you're already using it. I'll try to do justice where you feel like there was something for everyone in the session. Thanks a lot, Gopalji, for the introduction. I'll get to the slides. I hope the slides are visible to everyone.
Yes, we can see.
Yes. Great. So I'll get started. So basically, the introduction bit is already done. I was one of the founding team members for Facebook in India. Basically, first hire for the platform team. The goal for the platform was to cut down all the spam that comes on Facebook back in 2010. Like right now, the situation is very different to what it used to be back in 2010. It was a pre-IPO company. People would not recognize it compared to TCS, Wipro kind of companies in India. The culture was very different. The startup culture was not there at all. So if you say you're doing a startup, one, the word was not known to everyone, and two, entrepreneurship was not so great aspect. Like considering a service over a business was always a mindset that I've seen as a shift. While I went to Facebook, I'll not talk about the companies I worked for, this and that, but the bit is like the journey started like this. So God has been kind to me. Like I was visiting Hyderabad for one of the projects at HPCL. I finished a project as a consultant, Cisco consultant in Mumbai for Bharat Oman refineries. That went well, and then the company I was working for at that point of time decided to send me to Hyderabad. I got to know there is an opportunity for interviews for Meta. So by God's grace, I was at right place, right time, and then I got through it. I joined Meta, and that's where I got first time exposed to machine learning, and these are all statistical models. So some students at Stanford, they joined Meta, and they were doing some of this bit. They were visiting India, and then I got a very good exposure to solving these problems. And then rather than just writing automation scripts and queries at that point of time, I got like that first time exposure to it back in 2010 to write systems in machine learning. So what you see in Gmail, where your mails automatically get classified into spam and not spam, or maybe commercial, social, some buckets are there that you can actually create in Gmail. So that's actually a classification task done by statistical models. So that was my understanding at that point of time when I started, and then we were able to classify 90% bad actors very accurately that year, who were actually either creating spam or they were actually doing credit card frauds on Facebook, and it was pretty well understood. And that's where my journey started. After Meta, actually, I joined EA Sports, where I headed their mobile team, and mobile team did not have a data science function at all. So I started their first data science team. Again, God was kind. I got those mandate in a large company. At that point of time, it was 32-year-old company. And I figured out like the games would need something around not letting go players who play games like FIFA, Madden. These are the games which are pretty popular at one point of time, need for speed. So how do we retain these people? And mobile just got in at that point of time. So I got into a journey where the websites were pretty popular in 2010 and the mobiles were just coming out in 2012. So in 13, I actually introduced this whole thing. I joined EA Sports in 2013, and I got a mandate to form an AI team there. Back then, we were calling it data science team. I set up a team in Romania, in India, and USA in the headquarters. And we built a system to figure out who will leave the game in next 7 days, who will leave the game in next 14 days, next 28 days, how to retain them back into game. People who, so we would call it as a churn prediction model, and then retain them back into game by giving right offers before they even decide to leave. Similarly, my team built a product for spend propensity. So people who would play games for free and they will not spend, how do we change the difficulty to make them spenders? How do we dynamically make them spenders? If they're spending $5, how do we take them to $20 bucket? How do we take them from $20 to $100 bucket? So this was all done like back in 2013 to 15 time period. So I got that exposure. God was always very kind where ahead of time, when you get exposure where there is actually big data, you need a lot of data to actually make these models to act a little accurately. And that's a challenge when you start up on your own. Until unless you don't have projects and clients where there's enough of good quality data, building AI systems was a challenge. So after this, I joined a startup that was in Austin. I was director for their technology and products. I worked for verticals like healthcare. MD Anderson was one of our clients. We implemented some of the very good systems in oncology space and research space for them using AI. And then Ascension Anthem for insurance was some of our clients. So, I mean, I got exposure for BFSI, healthcare, insurance as the segments for US and UK market. So those are the verticals I was focusing on for AI. After that, I started Spotflock. We were focusing heavily on e-governance projects because we realized most of the companies don't have enough of data, and we chose government projects as a way because there is usually a high volume of data and there is an opportunity of like building something good if you get the right coordination. And we got the coordination in Haryana, Madhya Pradesh, Telangana. We chose these states. We started to work and develop some of the solutions. Currently, Spotlock is valued around $60 million. Fund from US has actually given us that term sheet. Overall, we are doing well, and now I'm actually moving on to another adventure. A group from US has reached out to take up a co-founder and CTO role for them. There are certain verticals we'll be focusing on, like telecom and fintech. So that journey is going to start soon. But I mean, that's the kind of background I have. But again, how I got started onto AI, it was like God was kind for sure. Otherwise, I would have been just a Java consultant working somewhere else, trying to figure out at this point of time how to get started on AI. So I'm really grateful for that. So I'll get to the bit of it, what we are trying to cover in this. I'll quickly talk about history and basics of AI. I might be looking at other side of the screen because there are two screens here. I have presentation going on one of them, and so don't feel that I'm distracted with anything if I see somewhere else, but there are two screens. So just giving you a little background to that. We'll talk about what is automation in AI. This is very important because half of the places where company execs are taking decisions, a legal professional, a doctor is taking a decision, a professor is taking a decision. We don't know exactly whether it is AI or it is automation. A lot of you might be knowing it, but generally, how do we really, what's the rule of thumb to figure it out? I'll talk about that and we'll discuss that. general trends in AI. Then we'll talk about what are the agents. So what is an AI agent basically? What do you build and you define as an agent, and how does that work? Some use cases around it. Then definitely we'll talk about AI and ethics, a big thing where we'll do a lot of discussions. Everybody would have their own opinion on ethics. And then the implication on socioeconomic factors, like what changes, how do we really tackle some issues that would be created with introduction of AI? What's the positive bit of it? We'll talk about some of those. But as you see now, the quiz has appeared on the top after all of this. We'll start with the quiz. I want all of you to participate. I don't want to induce sleep to all of you in this 45-minute session. I know all of you are very active participants, but again, let's start with the quiz. Feel free to answer these questions. Ask me questions at any point of time while I talk, because rather than using the 20 minutes at the end of the conversation, if we keep it during the session, probably it will be more meaningful and more helpful for us. So here is the quiz. So there is a room, and what you want is, in the room, when the temperature is equal to 25 degrees centigrade, there is an action that is required. The action is, if the temperature goes to 25 degrees centigrade and the action is done on the air condition, what do you think? This is AI or not? Do you think this would be an intelligent system trying to do this? Anyone can answer this question. Please feel free to.
It is more automation.
Great.
Yeah.
So we'll go to the next question. Similar product based on heat pattern. I'll come back to you because you will have to help people understand why you believe it is automation, and then we'll discuss. And I'll go to the next slide after that. Based on the body heat pattern regulation, like you have to control the air condition. Like, how do you regulate the temperature based on the body heat pattern? If there's a product like this to be made, what do you believe? Will that be automation or AI?
I think this needs a little bit more intelligence, right? Yeah, Anurag, go ahead. I am not an engineer, so I thought I can guess. You all are
No, I
engineers.
think everybody, I want everyone who is non-engineer to guess, because end of the session, pretty much everyone should say they know AI at least now. That's the value I want to really create.
AI needs intelligence.
Yeah, so this should be AI. Yeah, this should be, because your body heat pattern is a little bit more intelligence rather than just a number.
And it also involves feedback. Feedback.
Yeah, feedback, exactly, yes.
Right.
Great.
So body heat, and then we'll have to add genders to it, age patterns, and so on. A lot of
Surface
parameters.
area. Yeah, surface area and all that, yeah. Multiple
Right.
things.
How do you capture it through risk, through the external sensors and so on? So there is a lot of elements that comes into picture.
Great. So some people know this, some people might be introverts, as a lot of intellectual folks are introverts. I discount them from the answer, but again, like, feel free to ask me questions if there is something that you believe, like people have answered this. But why we believe the first one is automation and the second one is AI. I'll just break it down in a very simple way. The first one has a fixed condition, whereas the second one, we have to figure out what is the condition. If the condition is figured out with the second one, there is little intelligence needed to decipher that. So word pattern exists there. And whenever we are trying to find a pattern, there is little intelligence needed in things. So analysis comes into play. So we'll get to the next bit of it. This is a little interesting. People have answered this. How do you make alarm clock smart? So just take a shot at it. We can collectively answer this, so people can just keep adding points one after another. So you have an alarm clock. How would you make it smart?
So should I answer, or anyone else wants to
anyone?
answer?
I mean, like, you can start. Anyone can then add to it.
Okay, so the alarm clock smart right now, because I am also a sleep doctor, so I know this part. You want to wake up when you are in lighter stage and when you are not in REM sleep. So if you have alarm clock which is attached to your, let's see, watch or whatever way, and also they can know about your circadian based on your body temperature and multiple different things, then it will wake you up slowly, gently when you reach to that light sleep. And when it is very easy to wake up. Otherwise, what we call sleep inertia, that means when you are in deep sleep or in REM sleep, it's hard to wake up suddenly. And that's why we want to avoid that time. So yes, if you want alarm clock to be smart, alarm clock has to know your body. So it should be AI.
Great. Anyone wants to add anything? I think the gods have spoken about the subject.
Yeah, yeah. I
I'll
think
fall
that
short of
was pretty.
explaining.
Yeah, it was pretty spot on. I was going with the circadian thing as well, but she's already covered it. So that was one of that was one of the elements that is important. Yeah. So other thing could have been sort of capturing the patterns as well. Let's say if I don't give an input. So through
Right.
my general behavior of interacting with my devices, these days we have smart things around us. So we could capture some kind of data through that and make sense of it. Yeah.
Great. So is there anyone in the group who comes from defense background?
Yes, Sridharji, I am from
Great.
business background.
Great. So I actually take these sessions at College of Defense Management, Air Warfare College,
Hyderabad.
DRDO,
Hyderabad.
Hyderabad, Delhi, yeah,
Okay.
Pune, MIT. So I've done this for a while now. So that's the reason there is gun next as an example. Don't mistaken me for aggressive behavior. But now you have to design a smart gun. And I put this question to you, how would you do that?
There are many factors. In fact, a gun, when we mean it is not in a gun in a general term, is not solely a gun which is carried by a infantry soldier or a foot soldier. There are guns mounted on aircraft. There are guns mounted on vehicles. Even the artillery guns are also guns.
So I'll simplify. Sorry, we're not going to the depth of subject. It's only a
No.
handgun, like a small handgun that you have to design. I'm just like making everyone think about anything can become like from simple alarm clock to a gun. Anything can become
Right.
smart and intelligent because that's what we need to start looking at once we reach end of the session. So
Correct.
if you can just give a few factors, if you're using a shotgun, a small gun, basically handgun, how would you really make it smart? What would you expect from it?
Okay,
So-
can I just say
Please,
something,
please.
Ashutosh ji,
Yes,
and you
Sarita
can,
ma'am, please go ahead. Please go ahead.
and you can correct me. I recently heard a news, okay, that there is some form of smart use of gun where it will be locked, or there is some form, I don't know, but I heard a news that you can make guns smart in that way. And now you can go ahead.
Yeah. Just to add to that, there is really, I mean, I've seen some demonstration as well. There are smart guns these days, and you can literally bind it to a specific person, and it can only get unlocked at a certain time.
Yes,
But
yeah.
yeah, there are dependencies of charging it and maintaining IDs and so on. It has a docking station just like old cordless phones. So yeah, there are smart guns. But when we say trying, excuse me, when we are talking about making something smart, I think there are a lot of dimensions to it. And gun has so many implications that making it smart, we'll have to decide in which dimension are we talking about. Are we talking about safety? Are we talking about other situations. So yeah, I mean, there would be
Absolutely.
multiple ways to
Absolutely.
look at it. Yeah.
Yeah. So
Great.
Shashikant ji, sorry, Mr.
Sorry,
Sridhar.
please,
Can I say
Ashutosh ji,
something?
please go ahead.
Yeah,
Please.
so Shashikant ji was very, he actually made out some very important points from the safety point of view. But I would have a few more things to add to it. So, when the primary objective of holding a gun is to what? To hit the target. So my objective of having a smart gun would be to have a smart sensor along with it, sensor and a feedback mechanism, so that the aim, the sensing, and the firing is perfectly planned so that it hits the target. So to that
Right.
extent, yes, making the gun smart will have a smart sensor and a feedback system to operate it. Plus, there are other things when you fire a gun. The recoil. The recoil is something which also affects how the bullet will hit the target, or it will hit the target or not, or will it be misaligned with the target. So all those factors should be taken into account by a smart gun. And I mean, this is
Great.
my opinion. Yeah.
Absolutely. So I usually have a question after explaining a few things to defense folks, like how would you design a bulletproof vest and make it intelligent. And I typically cover this bit where a gun has to carry the inputs of somebody hits you. Can you identify the dimension? Like how it happens with the cricket ball. You know periphery, you know the arena where you're in war zone, probable places, the trajectory with which the bullet would pierce the vest that you have. Can we capture some information, send it to guns, to snipers, or some other automated system? I mean, like we discuss typically these kind of scenarios too. Great. So we have a great audience. I mean, like you all mostly are thinking about it, right? I'll just put some aspects here. So we'll just quickly talk about alarm clock and the gun bit. So things like, I mean, definitely this doesn't cover everything, but again, as we heard it from ma'am that we should build a smart clock which should listen to the signals of body. So any system which you want to build and like using AI and you want to make it intelligent, primarily you need to figure out signals, be it like a gun, be it like an alarm clock, be it anything like an AC. You have to figure out like what is it that we should capture as data. So to get the data right, you need to get the right signals. And once you actually capture enough of volume of data, from that you can actually arrive onto certain behavior and patterns. So most of you typically know drawing correlations was something that we all have come across in our walks of life, that we draw correlation between certain metrics. So typically, while we build any AI solution, be it in machine learning, be it in computer vision is something where we visually capture something with different kind of cameras. Or you're building a chatbot, which is a natural language processing system or natural language generation system. Typically, we again do the same thing. We have to capture signals. So, I mean, example is like if somebody is copying someone's answers and they are just speaking it out, maybe this writing style, we look at handwriting. There are these signals that when you are using intelligence and you're doing forensics kind of work where you're trying to figure out what's happening and you're applying a certain pattern recognition mechanism, you're looking at signals. You identify metrics. So here, like we say, can I capture sound in my device? And can I figure out somebody snoring or whether they're actually having a sound sleep? Because there might be a correlation between sound sleep and snoring pattern. So there is a new device that has been made, listening to the cough. We can figure out like what exactly, whether somebody's having pneumonia or not using that device. I mean, that's actually right now being sold also for veterinary systems, and they are actually now trying to do that for humans. So it's in process, but again, like there are these kind of devices that people are working on where you can use whatever as a professional, as a doctor, as a lawyer, whatever mechanics you're using of your own intelligence signals. If you can put it together for solving the problem, and you know these problems are coming repeatedly. So something is repeating, you think about either automation or you think about like building an intelligence system. With intelligence system, you know the patterns might be maybe 3 or 4 that are known, and the more of those patterns will evolve as we actually set it up on a AI system. I'll get to a little more details as we move ahead. So typically, we'll actually capture these kind of activities. We have to identify what are these signals. Once you have these signals, you can actually start. That's your first step towards like building an intelligence system. Similar stuff we discussed about gun. This is not a perfect solution to everything. Please feel free to ask me questions straight away, like rather than putting it on chat. I don't know if there's a decorum to follow on this, but again, like I might not be able to go back to chat. I just saw a pop-up here because it's in a presentation mode. Please feel free to ask questions.
So maybe Sridhar, we can take these questions once
at the end of it.
At the end of it. So if
Great.
People who are putting those questions in the chat box, we'll take those questions later on, probably.
Right. So for this question, I'll just quickly answer it because we are on this slide. No, so data is actually a collection of signals. So is signal and data being used in this talk as same? No, we are not using them as same, but I'm saying signals are metrics. So you have to capture these variables that account to a kind of conclusion. So you are looking at a kind of result. The result is making gun smart, but again, you would have certain objectives, certain goals on your mind to make it smart. And to do that, to achieve that objective, there are certain variables that you know are correlated to this particular metrics, to this particular outcome. So while you put all this signals, which is metrics, or you also call them variables, when you collect all of this and you put it together into a database format in structured or unstructured way, that database is collection of information. That collection of information is nothing but these signals and this information, which is captured at a particular cadence. So why we call that signal? Because there is a frequency at which we are collecting this information constantly. If we look data at only a point of time in isolation, probably we won't arrive onto a pattern. To arrive onto a kind of pattern, what is important is we look at a cadence or a frequency at which the data is being captured. I hope I answered it, but again, we can discuss it at the end of the presentation.
Yes, thank you.
Great. So for folks who are listening and discussing automation and intelligence for first time, the rule of thumb is pretty straightforward. If there is no fixed frequency, and if there is a if then else kind of condition that's arriving, and you're using a fixed hard-coded mechanism to solve something, like as I said in the first quiz, that you want to design an AC air condition where somebody walks in and you want to switch it on when the heat goes up, you're just turning it on and putting it on 25 degrees centigrades. So in such a scenario, there is a if then else kind of criteria, and these are fixated rules, and there is no pattern that evolves out of it. So and there is no probabilistic mechanism also, like probably this is happening, possibly this is happening. The moment we answer any question intelligently, you would see these words would occur in our sentences, that probably I believe, probably this is what is happening. So there is a probabilistic approach to something, and there is no fixed if then else kind of approach. There's no fixed process. It can happen at any point of time. So it's not like at 10 o'clock, the AC is to be turned on and it becomes 25 degrees centigrade. If there is that kind of scenario, for sure, it is automation. But do we need to use automation separately and intelligence separately? Probably no. Automation can be a building block. It could be the first trigger where the automation would actually trigger the intelligence. There can be scenarios where these can be independent. There can be scenarios when solving a business problem or a real world problem on piece of paper. You can define that this is pretty much fixated problem. I can solve it like this with automation. This is having a randomness, but again, there is a pattern that is evolving. There is analysis. There is a probabilistic correlation between things that I'm seeing. There can be an intelligent system that can be made on it. So this is the primary difference between automation and intelligence. If there are any questions, please feel free to ask them. So, I mean, this is the primary bit of it. Like, if you want to, how do you start designing something which is intelligent? You have to just start looking at the parallel between the 5 senses. Definitely, we can discuss about the consciousness and other aspects of it. But again, there is no real thinking if there is no consciousness. We can discuss about some of those things. But again, for ease and for the scope that we have to cover within this time, let's assume like there is a logical thinking element and there is rational that chatbots develop. Let's assume that for now. Or maybe that's the kind of thing, because I'm saying chatbot, why? Because GPT is already in news, and you're getting to read a lot of news about how rationally a lot of things are picked up from historic data. So if we look at like memory, perception, like humans, they are different from machines from this intangible aspect of a bit, where there's memory, perception, anticipation, problem solving, decision making. Whereas like while you're building systems, there are systems now built where you can capture data from transducers or sensors in form of speech, in form of text, in form of files. And you can actually convert that into natural language. You can create systems for computer vision. You can take decisions based on computer vision, what you're seeing, what you're capturing, figuring out what that object is. Things like those can be done very accurately now. And then conversations, I mean, dialogue and conversations, not just like identifying, reading what's there in it, but again, having a conversation becomes like little interesting bit here. That's what is right now happening with ChatGPT. So these are like typically 5 areas. The moment in your mind you start thinking about building a system that you want to make intelligent, you want it to really act intelligently, or maybe there is a critical thinking element that you want to bring into any system. And you want to identify signals, or you want to identify the variables. How do you break it down? You break it down in your mind by thinking, as a human being, what senses am I using right now? So to solve that problem, you break down that problem into smaller units, say A to B rather than A to Z. And within that A to B purview, you will think about, okay, I'm using physical touch here, I'm using my eyes here, I'm able to smell certain things. If there is a transducer available for some of these things, we'll figure out a way from that. Otherwise, whatever is available, can we actually do? Example, I cannot smell smoke, but again, we can figure out there is smoke with smoke detector. Can I actually use that as a signal and an indicator to drive something? There can be automation of just playing the buzzer sound, but can I make this little intelligent and wait until certain point, or can I predict a level before the smoke will even come out? That's where the intelligence will come into system if you're making the smoke detection system. So I mean, things like those are actually to be thought through the first level. You don't really need data scientists or scientists to solve this problem. The thing is, if you have anything that you want to make intelligent, you have to just look at your five senses and how your brain is actually breaking down that problem and solving for it. Then you have to think about how we as humans really have ability to think on the feet. So what does that mean? It means that probably our brain in that moment is able to think about 5 or 6 criteria which are causing the correlation to the outcome. But there might be more of those criteria which eventually evolve when we actually run into critical situations and we find further more solutions to the more than the known solutions. So that's where the critical thinking objective will come. And for a scenario like that, if you are able to think of more signals, I mean, example, any critical thinking question that we ask during interviews, like how many, you would have heard these questions for UPSC or IT jobs typically, that how many planes are flying over Hyderabad right now? How many planes are flying over Delhi right now? There is a logical approach somebody would take to break it down. So you start from an assumption and then you break it down by saying, okay, fine. I believe there are these many carriers. I believe these many flyers would typically go every day to the airport. There are 2 airports. There are these many destinations. So, I mean, you start breaking it down and there is a critical thinking and a rationally that you try to create, establish with the final outcome. The outcome, there is a question, there is an outcome that I know I want to figure out how many people really are flying. From that, I'll actually do a calculation of how many planes would be flying. And then there'll be a percentage of plus minus 10% to it, plus minus 20% to it. And we think of these logics this way. I mean, like there is a critical thinking element to it. So there is an obvious way of thinking about an intelligent system. And then there is a critical thinking that you need to add to it so that you can add further more metrics and parameters into your data to make it a little more complete. You'll have to do your bit of analysis with that data. You see what's happening. So we pretty much do this in our day jobs or whatever we are doing in some form or other. But now because there are algorithms, we are seeing certain things working and we are calling it very conveniently AI. We are not knowing the mechanism. I'm just trying to share the mechanism of how this really works. Based on the outcomes that we get, there might be certain test trial and errors that we perform in medicine, or we do it even in engineering and other walks of life. Interesting, some fail and some really are successful. Based on that, we decide this is the best option. I mean, how humans think exactly, we are trying to recreate those algorithms, those steps even in AI. And those mechanisms really help us to get the action perfect. Ultimately, when I say I've succeeded as a human being, the important aspect that you see here is like you measure impact. You have to decide what the final KPI with which I will decide my AI is working correctly. So there are, in theory, mechanics of Turing test and other things that we talk about. I'm not getting into details of that right now. But the best way to do something as of today, and what we will see furthermore in coming days, because now this is becoming commodity and everybody's putting AI into everything, even though it is true or not. Now you can very clearly see that it is automation or AI by asking a few questions. While we buy ACs and washing machines and fridges and whatnot, saying that is intelligent, whether it is intelligent or whether it is only taking signals and then you are defining if then else. I mean, some of the claims might not be true and we can just figure it out very easily. But ultimately, you have to practically see in the world of commodity of AI, you have to see, I'm predicting that somebody would get cancer with 99% accuracy, and it is about someone's life. And if there is a false positive there in my prediction, there is something absolutely wrong. So that's the kind of impact this system can create. And definitely it will go back to the ethics part of it as well. But on the other side of it, if a gamer, if I predict him, he will churn and he still continues to play the game I mean, it is still good. So kind of impact that I'm creating with the intelligence system, kind of action we are going to take with that intelligence system, we need to know exactly the consequences, where we are bringing this, look at the kind of data we bring in, look at the data that we are capturing, whether it is having biases. We'll talk about this in ethics again. But the reality is like the bias with which I am training a system as an individual, Sridhar might have certain bias and he might try to prefer. For example, you will find this in news that Amazon had this AI system built in 4 or 5 years ago where they eventually had to shut it down. This was for hiring people, and it had a hiring bias where they were not hiring women for leadership roles in certain roles because that was the historic data pattern, and it just replicated that pattern again and again. So we have to train these systems to come out of bias, and somebody has to observe. So technically, in future, we will see humans will work to tax AI. Humans will work to fix these problems, and some of the mundane jobs, the monotonous job, will eventually go on to AI. That's the kind of future people typically in industry are thinking about. So I'll move to the next slide. So I'll not go into details of any of the algorithms. I would recommend to read the book. I'll see if possible I can get some way to share the PDF. Have a look at the book, because if you are interested in understanding algorithms and how people loosely use these keywords and jargons, whether they know it or not, you'll actually get that part very easily after reading that. But here I'm just trying to explain there are few concepts and few keywords. One important keyword is machine learning. And this is technically as good as statistics and the quant models that we have been using for over 2 decades or more, especially like anything where we look at the child growth charts, or we look at the sonography data of expecting mothers, where we predict how the growth would be by the end of the pregnancy. I mean, we have been doing this for years. I mean, it's not a new thing, but the point is like the enterprises would come, larger companies would come, and they know how to sell it really, really well. So it'll look like it's packaged again in a different way, and it has been there for a while. So when we talk about machine learning, we're talking about statistical models. There are a lot of algorithms, and these are all equations. I mean, if you look at this, this is Bayes equation where my pointer is right now. And Bayes equation for probability, I have one examples in the slides to show you how the magic of AI really is gone the moment you look at it from the equations perspective. So I just want to cover that from that aspect. But again, here I'm not going into all of these, but again, we are throwing all the data to a mathematical equation. You can imagine it in your mind. And the sigmoids and the linear equation or polygon, I mean, you can imagine what structure is getting formed, evolved from the variables that you're giving in an equation. More the variables, more equation you need to create, and ultimately all the data that goes through this finally created equation gives you outcome, which means now you have a standard equation. You know y is equal to mx plus c, and this is a straight line. Every time I'm just changing one variable, the other variable output is coming out. You can imagine it as simple as that. All of those models that you're seeing here have that kind of mechanism here, where in a mathematical equation, you pass certain variables, you add further more variables to it, and the outcome starts coming out of that particular system. Neural networks are a little more complicated. Gaussian mixtures are a little more complicated, because if you have studied it during engineering or your physics as part of your background, probably you would know how they get a little complex. But again, this is where this is like statistics, this is like mathematics, and all that has now come back into form of machine learning. And while you apply this knowledge to much larger data set, where we're talking about like crores of records, millions of records, typically that's where it has to become a little deeper, because you're talking about multiple signals, multiple variables, which might have correlation to the final outcome. And it just gets a little complex, which from a normal human perspective, when you think about, oh, I have an Excel sheet. On Excel sheet, I can actually look at like these 20, 30 columns, 60 columns and try to find correlation. Or maybe I'll do a MIS report and do a visualization. That is a good way to get started with your problem statement, for you to understand, for you to become a little more aware of critical thinking approach you need to take. But eventually these models, when you start throwing data to these kind of equations, you'll start seeing further new pattern. And from that pattern, you'll be able to figure out and make system intelligent furthermore. So within machine learning, there is supervised learning, where you already label data. Example, again, going back to emails example, where there is labeling a mail as spam. When you mark a mail as spam, next time that kind of content which is existing in that, those tokens, the lemma, the grammar, whatever you call it is all tokenized into mathematical numbers, weights. And next time a similar mail comes, the classifier classifies and says this looks like having higher weights of spam rather than useful mail, and it'll actually move that content, that email into a spam box because you have done that kind of labeling. But if you don't want to create categories, now the new Gmail that has more than 3 or 4 sections apart from inbox, that is actually kind of unsupervised learning where you don't label, you send data and you let computer decide what is common across all these emails, and then you categorize them. And then they evolved, they look at all of, they let the models evolve, they looked at all of the buckets that were getting created. And then they said, okay, this is social. All the social emails will go into this. All the promotional emails will go into this bucket. So they classified something, and then that was the end of the process. Whereas like in the beginning, they just let the system run and they were able to do all of this. And this is this process called unsupervised learning, when you don't label and let system classify similar content. I mean, which we do as human beings. When you tell a 3-year-old, you have given a star, you have given a square, you have given a circle, and then you tell them, you leave them without teaching them. First time, how do they approach? That is unsupervised. And when you teach them, like this, these are stars, put them into this particular bucket. These are circles, put them into the other bucket. These are squares, put them into the third bucket. This is exactly supervised learning. So not going into further details, but again, I mean, you can use these into pretty much any vertical, any walk of the life. We are doing legal AI systems right now. This is highly used for using Nyaya Samhita and IPC section implementation. So as soon as the FIR without IPC sections arrive, we can tell exactly what IPC section should be applied, and new Nyaya Samhita sections can be applied using the same logic. So we have used the historic data, we have classified them, we have used both unsupervised and supervised mechanisms and seen where this is landing. Then we give it feedback, as one of you explained in the beginning, that you have to train the system. I think Mr. Sashikant talked about it in the beginning, that you give feedback. So the moment we give feedback, the system gets a little better. And then ultimately you run it one more time. And then you see, okay, now the accuracies are more closer to what we expect. So quickly getting to the next part, I've covered one keyword of what is machine learning, very loosely, commonly used along with AI. AI is a bigger gamut within which, when we talk about machine learning, it is a subset of that. When the data set becomes bigger, we are talking about deep learning. I'm not talking about deep technology, but this is deep learning. When we talk about natural language, this is actually then called anything to do with chatbots, dialogues, Alexa, Siri, any of those kind of systems where speech is involved, text-to-speech is happening. You're seeing deep fakes where your voice is replicated. Everything falls into a larger bucket. Within AI, it falls into NLG or NLP. So natural language generation again has different level of intelligence. So basic chatbots, we have seen them into support ticketing websites, where again it's more to do with, even though it might be looking like automation, but it might be using some systems to give standard answers. Then there are template-driven approach where you select the bubbles and you say yes, no, some information you just give that way. And then there is something like ChatGPT, where you actually can have complete end-to-end conversation. A little insight into ChatGPT, while you think about how do I bring a ChatGPT kind of solution into healthcare or legal or education or any walk of the life, because I don't know everyone's background, but you can think about your own domain. We can actually use, we don't have to reinvent all the algorithms. I mean, you can just use Llama and ChatGPT's GPT, Turbo, any of these algorithms, which is created and open sourced. You pick them up. You don't use a generic data set. You give your own historic data to it. So example, a patient walks in today, and we know seasonally patient, when they walk in the month of July, August, when the rains start, we would know what are the probable things this person might be carrying and kind of infection they would have based on historic data. It might be different scenario like COVID, but again, like generically, we know there is a pattern and known scenario. When the dengue season would actually be on, you would know very clearly, like highly probable blood test might turn positive for that. So I mean, like, how do we use that? There is a lot of historic knowledge, intelligence that you have gathered over time. Similarly, when we take all that knowledge from PDF files, documents, and for subject matter experts like you, and we put it into a GPT system, The GPT can become either makeup GPT, the GPT can become a healthcare GPT. Within healthcare, we can make it very specific to a pediatric department or maybe ortho department. We can actually use that particular knowledge base. We can train these systems with all that historic data. We can ask questions. If the system answers it incorrectly, you would have heard a new keyword called prompt engineering. So when you give a question and you prompt it, the system answers back. This is what is prompt engineering, and how do you make it better? When you give feedback, that's where the engineering dimension comes to it, which means I ask you a question, you give me some answer, and I correct you back saying, no, 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 I think this is what it would be. When this question is asked, can you use historic data? And I believe this is how you should answer it. The system goes back, revisits the algorithm, corrects the equation that was formed, and then again generates the data out. And then you see with the prompts given to it, the system learns. This is what is prompt engineering. So you can create your own GPT systems. You don't have to give away your data. You can maintain the privacy by making them hosted on your own servers. And by your historic data, your own knowledge, you can actually make them very much refined as of today for any vertical. And we are doing these kind of projects. That's why I'm just sharing that information. Not like I want to do this, do that commercially or anything, but if you're thinking to get started in that domain, this is the perfect time to actually convert all the years of knowledge in some format, how you diagnose things, how you do prognosis, how you solve for a problem. If you can think about it and you put it down in a piece of paper as a process, you can use NLG systems to do that. That's where we stand in the world of AI today. Again, like as I said, I'm not going into algorithm part of it, but just for your ease, how your brain can then actually comprehend what's happening. So when you give a sentence, you can figure out like a nominal phrase, a verbal phrase. You can do all of this, but you can figure out a name in a sentence. You can do a lexical analysis, figure out whether there is a punctuation mark, what operator we are talking about, which is the noun we are talking about, what's the adjective. We can do pretty much pause tagger is what we call it, and then parts of speech basically. And we can also do NER. That's another keyword, which is name entity recognition. So what is the name mentioned in it? What is the entity we are talking about? And we identify those. So a simple example, if I have to give you, would be like this. On a call with a customer care representative of any setup, could be healthcare, could be education or anything, we cannot really do call quality check for all the calls. So we randomly ask people to pick up some calls and do that bit. Now with AI, what you can do is we can figure out who they were talking about with name entity recognition. If somebody says, I was really happy Steve solved this problem, the manager on duty solved this problem, I can find who the manager was at that hour serving those calls, whether somebody is positive or negative in their sentence, in that sentiment. So that is what is sentiment analysis. And we can do text to speech and speech to text, which means that if I take audio file of these calls, because there is technology which records these calls, I can take that, convert that into text, run these analysis, do analysis of what are the problem areas, what people are talking about right now, what's the current trend, why people are calling call center. We can do pretty much any of those things using these technologies, and people are doing it already right now. Moving to the third important technology that people generally talk about, this is computer vision. This is what like Tesla's autonomous vehicles are using, all the robots would use it. So where the eyes and the visual sensory input that we take typically is replaced with cameras and then other sensors, distance, ultrasound. There are these kind of sensors that we typically use in combination to get this thing a little accurate. And the cameras like LiDAR cameras would actually make it, laser cameras would actually make it much more accurate. There are night cameras. What you're seeing here is one of the defense use cases where generally in olden days, you would only know thermal activity happening if somebody's running in a camouflaged way in a dark place. But now using neural network, we can actually create possible faces and map it to suspects and their data also. So we can create a face on top of it with generative AI. So these kind of systems are getting deployed already in Canada and US. Right now, India is also working on some of these. But technically, you can use these systems for creating deepfakes. Deepfakes is not a negative term, though we call it as fakes. We think there is something bad happening because people are using that technology for a bad reason today. But ideally, I can create a virtual anchor, and we can. The ethics part is questionable in terms of if I'm cutting off somebody's job to be an anchor on a news channel. But technically, I'm cutting down on dependencies and reporting scenarios where I don't want somebody to go. So a drone can go capture the situation. I can create a news story. The reportage on war zone, I don't need to really send real people in those kind of situations. Similar stuff we can think about, like a doctor's virtual avatar can be created, and a patient really feels comfortable while doctors are really busy attending multiple patients. So deepfake is only technology where absolute replica is made, your voice fabric is taken into account, your videos are taken for training purposes from different angles and stuff. Irrespective of what is background, irrespective of what it is, we can superimpose, get exactly output as who you are, as if you're talking, and whether you might not be on present there. I mean, there are implications, but again, can we put legal boundaries to it? Can we do it in a certain way by signing NDAs, signing legal contracts? How do we put checks when it was used? Can we create ledger to know how the log looked like when it was used, executed with your permission, without your permission? Things like those systems can be built around it. But that's what the technology is. Deepfake is not really bad, but it's like it's right now without railguards being used. That's why we see these issues of frauds and like insensitive usage of it, like by entertainment industry. But we can definitely see some good use cases coming out in future. These are broader three classifications right now. I know like I took a little time to get to these three critical pieces, but again, just to summarize again, AI is the broader bucket. Within that, there is machine learning. When you have large data set and you're dealing with numbers and you're making prediction, forecasts, things like those, and the data volume aside, we call that deep learning. Then again, within that purview, there's supervised and unsupervised learning. Then coming to the next part, when it is speech, we talk about language, and this could be any language because there is grammar and language. You use the same logics and then you build it for different languages. So this is called natural language generation or natural language processing. And then the third bucket is computer vision. And then there is IoT, which itself is a subject to talk about, but these are Internet of Things, which means there are transducers which have become much more, I would say, intelligent as well as better at capturing data. And all the game has changed now, to be honest, because there is better compute, stronger computers. Your phone itself is like much smarter and much stronger in terms of compute. To 10 years ago, what computer we used to have, or desktop we used to have. Comparing to that, our phones are much more intelligent, much smarter, much efficient to operate. So because now there is compute available, all of this evolution has started to happen at another level right now. Any questions? I'll just take a pause. If there is any question, we can address that now before I jump to history and other things of trends and stuff like that, like those.
Yeah, I do have a question. So let's
Please.
say I want to build my own chat GPT and want to make like a diagnostic platform. So just imagine that I want to diagnose pneumonia, and I feed all the journals, medical journals, everything in that, and then ask ChatGPT to give a scenario and ask, so ChatGPT can tell me this is pneumonia or it's not pneumonia. Can I create my own?
Yes, you can as of today. So again, I'll go back to the thing of how you typically solve that problem as a human being, as an expert, which is like probably you look at probably
Yeah, sign
X-ray
symptoms and
or
X-ray and all that. Yes.
absolutely. So there is a stage before X-ray, like maybe there is the
Yeah,
cough, the
everything.
lung,
Yes.
things like
Yes.
those, all those that we'll capture. So
Mhm.
we run all of these parameters through. So there will be a questionnaire, a quick set of questions that you ask patient, or maybe you look at the patient and you realize the kind of cough they have. So we use all these signals. So the time somebody walks in physically, if you're analyzing or you're listening to any external signals of sound, or so basically there are these smart stethoscopes which can actually record the lung situation as well. Now we have that as well. So, which will not give you information of whether pneumonia is there or not. But again, that audio file is now available. I can use this audio file. I can use the question answer bit. And then if somebody is giving me X-ray, that's the ideal thing, because we are already doing that right now for one of the hospitals. We can process, we can tell with 95% accuracy. We can give that instruction that this is what is seen here. This is where the pattern is. and the senior doctor would actually look at it and they will approve or disapprove that bit. That's so we bring all of these small pieces. As you really break it down and you want to make it highly accurate, not just the chat part of it, but chat becomes the interface where you ask these questions, they submit certain things to you, and then the moment they do this, within nanoseconds, all the calculations are done referring to the conditions, situations. So for generic one, for sure, it might not be so useful for a lot of people, but again, like there are public health facilities, which I know in government hospitals, where we don't even have somebody who can read these reports and give us right guidance. So if we have a system like that in villages, this becomes very powerful. But probably in cities it would not be. But again, when there are complex scenarios where you want to refer journals and you want to see what this doctor's opinion would be, we can create personas of those doctors, their historic cases, and how they would have answered this particular situation. That is also possible with GPT, and that's happening as of now. So that intelligence is, so if you can give those signals, your white papers, your research papers, and I know in theory certain things are written in different way versus in practicality. So the HRMS solutions, hospital management, medical patient records, those are the mechanics where the transcription will happen while you talk to patients. Some of these systems will capture this, and this is not really that difficult. We are doing this in Indian hospitals too, where somebody walks in, they talk about it, we capture that transcription with their permission. Doctors are comfortable, they talk about certain things within that purview. And then that information is transcribed, and we look at the prescription written last time, the historic data that was there on that patient. And then we make certain recommendation. Doctor corrects that, which means they don't have to come and waste their time on that. They will choose certain medicines or they'll write something new based on the condition. And the system starts learning from that. The why aspect is something, if a hospital gets into a mode where they identify few interns to write why on behalf of the doctor, because doctor's time is valuable, these systems can be made, and they are being made right now. I hope I answer your question.
Yeah, thank you.
Great. So if there's anything else on this, we can take it up at the end of the session. I'll just quickly go to the history part of it. So I mean, we humans are really great at like making anything big, large in terms of possibility when we have to make money out of it. AI as a keyword like came out back in 1940s. Definitely there was low compute. Alan Turing is considered to be father of AI. There's McCarthy, John McCarthy. He was like another researcher who has done a lot of contributions to AI. And after that early dream of AI, definitely when you start about something new, there's a situation where a lot of people would, naysayers would say, no, this will not work. There are issues. And definitely compute power was one of the reasons, as I said earlier, where in 60s, 70s, it again, that keyword all of a sudden vanished. A lot of people stopped working on it. 1980s actually became the year when we saw, and we have seen perfectly, there was one of the logos that you might have noticed of John Hopkins. I mean, that was one of the places where I got a lot of data for healthcare. And healthcare has always been like trailblazers. Like as trailblazers, they have actually picked this up area where data is captured from transducers. There's a mechanism to find correlations. So they have been doing that in certain mathematical way as well. I mean, debatable for a lot of people, but again, I personally feel a good place to start learning AI is like taking healthcare data as a good vertical, go after it and learn, because there is nuances and seriousness of the outcome and the impact you can create if you go wrong and right. So you learn as a learner very well with that. 1980s, medical systems actually started to pick up AI again. There was a lot of extensive research money that was available with healthcare facilities, and they used it. And knowledge systems was again started to build in that era. In India, we see definitely earlier we used to see 15 years or 10 years of lag for technologies to come to India. So what we see in 90s and 2000 about like statistical learning and all of those, definitely we saw that as a commodity. So speech recognition, if you remember, 1997, 1998, when these computers had Windows machines and they came with Windows software, Microsoft Windows software, they had some speech recognition systems already as part of it. They had some kind of OCR systems, which is actually image recognition. So practically, if you look at these technologies, the research was always on. We had little limited focus on it because it was not a game changer at that point of time. And then every time you have figured out a mechanics and an equation to solve the problem, you needed compute to solve that, which was missing. Year of 2010, ideally, where the compute, the chipsets, They were bigger players. China went into different mode of manufacturing chipsets. Some of those things were happening. We saw great rise of AI, and right now that's what we are seeing. So I feel like that 15 years gap is now squeezed down to 6 to 7 years. So whatever is right now happening, we'll get exposed to that commercially. Worst case, everyone will get exposed to it in 6 years. If early adopters look at it, 2 to 3 years, pretty much you will have that exposure. 1% people, definitely they can have that exposure as of today. So deep learning is the current era. That's the history. So from 1940s, we have been on to a AI journey. It has been given different names, statistics, this and that. But the word artificial intelligence was coined. Neural networks as a concept was evolved in 80s. 40s, they created the word artificial intelligence. 80s, they refined it with like further more things. So general trends, what we have done here is a simple analysis of how many news articles in positive, negative we are writing about AI. So from 1985, there were news articles on New York Times website. And if you look at it from 2010, we clearly see that correlation. What I was trying to talk about in the previous slide, this is still 2015. We did not update this graph. But again, like right now, everybody knows what's happening. It's in news. Again, there was a winter kind of thing because of funding and all in 2019, 2020. But again, GPT really was a game changer where you can see how many companies have spent how many years already in different areas, speech recognition, video recognition, computer vision. I mean, there are final buckets within AI, and there are a lot of startups doing a lot of work. But that's the trend, it's evolving. Overall, people who are in IT, they know about it, that how traditional analytics was a big thing. Everybody was talking about visualization, graph charts, finding correlations, things like those. Then big data became a big thing. And this journey is from 2010 practically. A lot of people who would have started their careers in these areas, from those years, they would have seen this kind of stuff coming together. And then machine learning platforms started to come out, Azure, Microsoft, Watson. They have been talking about it for last 1 decade. And then people realize some of the problems are not getting still up to the mark. People start to look at intelligent process because that's where the money is in enterprise side. So the focus has been onto the enterprise AI in majority and the transformation of industry. And this is where now the service integrators who used to just build softwares, websites, and mobile apps, they have started to enter into AI because there are a lot of open source solutions. So you will run into people like me who will come and say, oh, we'll solve this problem for you. We'll build your GPT. We'll build your intelligence systems in your vertical. Or maybe they would just like to collaborate without pro bono. Why? Because you are subject matter experts, or they would like to engage you in some format so that your intelligence can be actually fed into these systems and these systems can become intelligent. Right now, the orange layer is where we are, which is DeepTech, generative AI. So the deepfakes fall into generative AI, ChatGPT falls into generative AI. Anything which generates the content completely on its own is generative AI. Then XAI is actually the new keyword that we'll get to here soon more frequently. This is explainable AI. So people want there has to be, so ethical committees are getting formed, and they want that whatever you're building, it shouldn't become a black box. Why something happened, you should have a reason as a AI expert why you're building a solution. There should be a mechanism to go back and say why it said with 90% accuracy that somebody is having cancer. What was the way of like traversing? What was the way of figuring out what data it used and how did it conclude? So we are working on XAI systems now. The last bit is this is a little bit in works now, but multi-model system is this exactly that I was trying to talk about, where you create one model to figure out the speech part of lungs, I mean the sound that is captured from that. There's one model created for the prognosis process. There's one model that is created for diagnostic process. There's one model created for getting the all text and everything put together. So there is a multi-model approach that you use, and then that gives you conclusion. It might not be a generative AI in speech format, but it will actually give you the conclusion. Using the conclusion and your historic data, you can then go and generate a summary, a patient summary or a situation summary can be created in the style you say that. I'm just taking healthcare example because we just spoke about it. We can discuss any other scenario at the end of the discussion, but that's how this typically works. That is generative AI, and when you break it down into multiple smaller models to solve different problems put together, that is a multi-model. So I'll take a break here. I'll just pause. Any questions that you want me to answer? Because then from here, we'll make it a little interesting in terms of if you want to build, you want to design, what are the phases of AI agent? Agent means that intelligent black box, which we want to make explainable eventually. But how do we design that agent? We have discussed it on high level with a couple of examples, but I'll just give you the framework. You can take a screenshot of that. I'll share the PDF file after the session for your reference at any point of time. But again, these frameworks are typically used by professors at MIT to help you design AI. When you say, okay, let's design an AI system, they'll just use this. In theory, this is how you have to start. They'll take it down. Any questions that you have before I jump into the framework?
Mr. Sridhar, before we get into that question answer mode, I just have one small query. How much time do you think we will take more for this discussion?
So I'll wrap it up pretty quickly because I'm trying to take questions in between. I know it's 8:46, 8:45 right now, and we have gone a little over time, but probably 10 more minutes. I just want to like walk through
absolutely no problem. Absolutely no problem. You can take even more time. That's not an issue. I just was being curious because
I'll not go through all the slides for sure. I've kept something very condensed. So I just want to take one example of predicting whether a hot air balloon would actually fly tomorrow or not.
Okay.
That kind of scenario where everybody can relate to it.
Right.
So I'll just go to the next segment straight away.
Okay. So I'm sorry I interrupted you in between, but if anybody has any questions, as Mr. Sridhar has asked, please go ahead and ask the questions. Otherwise, we'll continue with the session. Okay.
Cool. I'll get to the
back to you
bit now.
Yeah.
Great. So typically, this is the language that people use, and believe me, if you are in industry another 5 years, you will actually see very clearly any vertical that you belong to, that people would actually come discuss things, and you have to make them accountable. And for that, if you use these keywords, that what are the sensory inputs we're talking about? What is this environment looking like? What is, so rather than saying action, if you say actuator, the data scientist would actually be a little conscious that they are not talking to someone and they can sell anything who doesn't understand AI very easily. So you can actually use these jargons, at least, if not really into depth of it, because rest of it is your critical thinking from your vertical. But from a data scientist's perspective, if you use these things, these words as a way of communicating, they'll relate to it, and then they'll understand that you have some context of it. So typically, a rational that you put into something, a software that has actually a rational mechanics inside it, we call that as agent. Anything that we call smart, intelligent, in world of data science, we typically call it as agent. Inputs that we take in are called sensors. The environment that we are trying to change, which means the outcome, which outcome will impact certain things. Those things are that particular set of people or situation, circumstances, is environment. How we will do that action happens through actuators. Actuators would actualize what you really want. An agent is actually our replica using that intelligence and trying to do that bit. I'll share these slides anyways. You can feel free to take a screenshot. I'll move to the now simpler way of like putting it. There are 4 phases while you want to design an AI system. You have to define the particular problem statement, and you have to figure out a mechanics, a model to solve that particular problem, which I said as a critical thinker, you do that bit. You have to define very clearly, this is the problem, this is how we can solve that. So this is what this model means. This is not AI model, but this is just like your logic to solve the problem. Then you have to connect and discover, which means you have to find the data now to get that logic, to solve that logic, figure out the signals, variables, connect to that data. Now you have to discover the right algorithm. This is again where the data science folks will come into picture. But again, if you know there is correlation between certain things and you give that as a starting point, it just becomes very good direction to start for a data scientist, and they'll give you a better success in that scenario rather than like building something very generic and then you waste a month or 2 and lose hope on it. It doesn't work. But if you can help them with these 2 phases, the next 2 phases just become little easy. That will become very easy for them. So basically, the next phase is advise and assure, which means that based on an outcome that you have from the algorithm, you have to advise whether this is right or wrong. So subject matter expert would actually come into this particular scenario. And then the system, after the system is also advising, make this action. You have to advise the system that correct this or this is incorrect. How to correct that, you're telling that. But while system says this, I'm sure this person who is walking into the mall using the security camera and the walk style and what they have in their hand, they might be terrorist, and they're making that advice, and they have to assure you with a confidence saying 99% I believe this is the thing. If they are doing this and you pull somebody out and they are not, it's a false positive, that becomes a bigger problem. So a confidence score has to be there, because you have to fix your system that much. You have to go backwards. If it was 50% accuracy, confidence, you would be like, okay, let me keep an eye on this person. But when it is 90% accurate, it believes that it is 90% accurate, and you take that as an advice, and it goes wrong, then you have to correct the system completely because it's making very bad recommendation. Ultimately, what we do, we connect this. If you believe this is all working well, you connect it with hardware, software, some mechanism so that it can act. Actuator comes into play. And ultimately, as subject matter expert, you would say this is not working. This is not exactly getting there. I want at least this level of acceptance. And once you do that, subject matter expert would actually give feedback. Ultimately, the feedback goes back into a system where you can define the model again, you can refine it further, and then again you do all the process, and ultimately you get better accuracy. So these are the 4 phases. Typically, a feedback loop is created. Typical engineering system or healthcare system where you see that feedback makes the system better. Negative feedback, positive feedback, false positive, false negative, pretty much all the same terminology that we use in statistics and any vertical related to that. I mean, all of that just holds true here in this particular scenario. Quickly, I'll just get to the hot air balloon example. So let's assume you are actually visiting somewhere and you have to do this activity. You would have seen there are people who would not use many devices. They might just look at certain illuminance kind of device or things like those or some data, and they'll say, let's not fly today. Or today, this all looks clear and we can fly the balloon. So this is this typical problem statement where all of us can relate, whether this activity will happen or not. How are we deciding? So the person is looking at the outlook, whether it is rainy, whether it is sunny, there's temperature, whether it is mild, whether it is too hot. There is a criteria of humidity, whether this is normal, whether it is too windy. Things like those, you have figured out these are signals basically. And now I need to create data. So there is a posteriori probability system I have to pick up. One of the algorithms I'll pick up. I need to throw all this data into that particular equation and want that equation to tell me probability of occurrence and probability of non-occurrence. And with probability of occurrence, I'll know whether I will have this event in certain scenario. So I'll capture all the historic data of 2 years, remove all the outliers for certain situations, and then use this as my historic data. So using this data, now I create a mechanics equation in which now I'll fill today's data. What is happening today? What is my outlook today? What is my temperature today? What is humidity today? And what is the windy situation, whether it's windy or not? And I want the system now, the final equation, x is equal to whatever it is. The x is my outcome here, whether it is true or not. That outcome will come using this equation. I'm just showing, I'm not saying we'll get into calculations, but I'm just showing how this happens. So we define the model, we identify the metrics, we collect the data, we enrich the data. What I mean by enrich the data, probably there will be some places where data is missing. So we'll figure out how to fill that data. We clean the data, we remove outliers. There was one particular day where there was a storm, and then based on that, if I decide something, and still we flew because of certain other reasons, which might not be the right data to take in account. So we'll remove that data. So things like those we'll do in this stage. And then we'll figure out, using my rationally critical thinking, what's the right model of my brain to think about it. This is how I find correlation. And closest mechanism of critical thinking will apply and see in mathematical models. So data scientists will do this job for you. They'll figure out exactly which algorithm has to be applied. So we pick up, say, Bayes classification mechanism here of occurrence and non-occurrence, because that's the outcome here. I want to know whether it will happen or not. I connect this data, I discover exactly what's happening. Finally, do we arrive on to right equation? You can do all of these basically even on a piece of paper if you have limited data. When the data volume becomes big, it becomes a little difficult for us to predict. Now we have defined the signals metrics. Somebody asked me questions whether data is signals. This is the answer. You can clearly see how the data is coming. So the outlook, humidity, wind, historic outcome. So we have historic outcome. This is very important, fly or not. So I'm correlating each one of them separately, and I'm correlating all of them together, which means a complex equation is getting formed in this scenario. So I can create, so this is like a little bit of math. If somebody enjoys this, when you get the slides, you can go through this. I'm not going into each one of this part of it, but when you look at a frequency table for each metric, whether there is sunny, overcast, rainy, I'm calculating it based on how many times rain happened, how many times overcast was there, and what was the outcome. I'm trying to find all the rain and fly or no fly, all the temperature, fly or no fly, all the humidity days, fly or no fly, windy, fly or no fly. I'm finding correlation for each one of them, and then we are finding a common correlation for all of that together. And with that, you will know for a day when there is overall, for a day when it is sunny, for sure you fly. When there is overcast, still you fly. You will know that kind of information will start coming out from the overall data. So I know which was our intelligence, human intelligence. An expert would look at the sky and say, today we cannot fly, because in their brain, they're thinking about all of these criteria. Now we have taken all those criteria from their mind, we have put it down onto paper, and we have defined the logic. Now the next step is we apply the chosen model, all the calculation happens, and then we look at the outcome. That for this particular condition, tomorrow, can I fly or not? And it will actually give you a final outcome saying yes, 57% or no, 42%. So 57% is still better rather than 50-50%, which means that I'll fly. I'll not use this as a reason. I'll use my own intelligence today. And I'll decide, okay, let's fly. And then if the condition actually said 57% and I incorporate today's data back into this data set, this 57 might become 60% tomorrow, because I've added one more record into the table which was seen here. Now you have one more day's data where you have added the signals and the outcome of yes. Whereas the system said yes, and then you were reinforcing that, okay, all these metrics mathematically calculated have a stronger correlation when they come in combination, and there is a probability of flying that day. This is how typically systems work. So this is one simple example. There are more complex algorithms that we have to deal with, but this is how it typically works. Ultimately, same thing, like what I said, 57%, and then you decide, then you think. So rather than discarding saying we cannot implement AI, if you use a semi-human approach there and you say, okay, we'll decide and do what we have to do, but let AI show us the results, and then based on it, we switch gracefully into the whole AI thing. That's how it would be. There are slides on ethics. If we have 5 more minutes, I'll quickly go to the ethics slides. This is a game scenario. I'm not covering this right now.
Please go through. Please go through. Thank you.
So this is one more scenario where you can imagine Amazon as a thing where these are all the historic users of product. Here, though it says churn, but let's imagine this as Amazon, and they're buying a particular product, say keyboard. This is a very simple example, so there is no magic in it. But again, that's what we want. Like we want to break it down. So there will be factors like here when somebody is leaving churn, we are looking at session per day, sessions, how many times somebody is visiting the product, that is session basically. The length of duration they are using the product, age in the product, on which level they are, device they're using. This was for churner. On product identification, we'll look at the price point somebody spends on, number of minutes they spend on Amazon, kind of different products they are buying, things like that. We are profiling them is what I'm trying to say. And then once you do this thing, you create profile of Sridhar. Today, Sridhar is using Amazon and you want Sridhar to be targeted with right offer. So it will actually look at all the people like Sridhar who have done that bit in past. When he's buying a keyboard, you identify what other people have done. And then you show on a pop-up, Sridhar, you have special discount on mouse. Would you like to take a mouse along with keyboard? So, I mean, that's how these systems typically work. So when you see a pop-up showing as a deal offer something, if the company is large enough, they would have implemented AI, and this is how they typically implement it, where they make intelligent system and they try to bring it all together for you. So you can imagine like how you are data for them, and everyone's data together is actually helping them make a better recommendation. So this becomes very easy. You see many of these kind of pop-ups if you're playing Candy Crush kind of games and things like those typically. So to the final segment, there is socio-economic implication that we'll quickly get to through ethics. But again, typically ethics is one important area. IEEE has been discussing. There's a document that I read in 2000, 15 of 300 plus pages, and that would have evolved now in thousands of pages where they keep refining. Some intellectuals, they come together, they try to figure out globally how do we solve for this. And every country has its own mechanism, its own policies, laws, weaker, stronger, and people choose for that reason to go to certain country to get data. But ultimately, while we work as subject matter experts anywhere, the conscious decision ideally should be with army. I believe it's the other way around. I discount armies and military because the ethical mechanism works a little differently. I mean, like, that's my personal consideration. I might be wrong, but definitely the basic remains same. But again, in a situation of war, you have to be a little different. The ethics changes, the framework changes. But for generic perspective, we have to ideally look at human rights for sure. We have to look at like overall well-being of people. There has to be accountability of what we say, and the system is actually not accountable ultimately, which means, like I said, somebody is having cancer and the guy dies because of depression ultimately, thinking he had cancer, which is like the saddest thing to happen when we figure it out later that the person did not actually have had cancer. So things like those, so who is accountable for it? Hospital or the AI or the person who built AI, the data that was used, subject matter expert. We need to define those parameters. And then, as I said, like explainable by AI is the new thing, XAI. So transparency is what we definitely need. Why something is being recommended. A lot of data scientists would just use something and build something and deploy. If we can actually make them a little more, we can push them a little more, nudge them gently in terms of like explain. Can you add a module for explainability? Can you create a log where what was taken in account and why? What correlations are there? Things like those, if we can actually get from them, probably that would be a good starting point, if not exactly. And then, as I said, like deep fakes, as it is misunderstood because it's misused. So we have to create awareness as we are still facing challenges of OTP being stolen, which is not an AI problem, but again, banking frauds. This is because there is not enough of education and awareness, and we'll always run into this. So by the time I would enter my late 50s, the scenario would be very different of understanding the technology with Vision Pro kind of products coming and things changing very quickly in technology domain. But somebody has to educate us constantly. So definitely we have to do more sessions like these where we can actually make people aware of specific issues and where the ethical challenges would actually come. So in all the documents of IEEE, they talk about AIS as a system. So artificial systems or intelligent systems, because people can play with words and they can always get away when you have a legal document and when people really want to do that. So there are certain set of questions that we really have to ask, which we have just talked about on the previous slide. But again, these are the questions if somebody wants to ask, and how do we really make somebody more accountable when they're building it? I mean, they have defined these questions in IEEE forums, basically. So there are challenges, definitely. Communicating complexities are there. There are ethical design challenges in AI generally. Then the way things are advancing very fast. How do we make people accountable? How do we keep it fair? Example, AI would actually solve a problem in much shorter time, but it has taken all the data and knowledge of like hundreds of real intelligent humans and subject matter experts. And then I put one human intelligent person on a team of 10 people. I mean, that cannot match. It's an unfair game to play ideally, which we will actually see in future would be a bigger problem in 8 to 10 years. We'll definitely run into many of those scenarios. How do we really maintain the abilities of engineers, entrepreneurs to innovate? We have to do that also because we cannot stop. We cannot ban it completely. How do we put things in right perspective? Ideally, we'll have to do that also. So these are the challenges. How do we do it? That's where like intellectuals have to think about from their own vertical. And if you believe you cannot use AI or contribute, this is the ideal area where you can leave greatest impact as of today. 10 years later, people will thank you because if you create documents and you leave it on internet of your domain, how to solve the problems and keep it within ethical check, whether to figure out whether it is ethical or unethical. In real world scenarios, how you have tackled these scenarios. If you put all that intelligence and you put down those questions for somebody in a survey to check, like these are audits typically, like how quality audits happen today. We can build those mechanisms which is missing as of today. And even if that is available in form of papers, white papers, people can actually take advantage and we can actually contribute in this world of AI very effectively as subject matter expert. You don't have to be a programmer. You don't have to be a coder to do that. Last bit. So this is about implications on socioeconomic side. Very controversial, but again, technically there is economic growth. It will help healthcare. It'll definitely improve education, which I mean, like it's happening. There is issue because we are not executing it well right now in edtech domain, but again, there is a lot of potential there. And then it increases accessibility. A lot of people with disabilities have like options as of today. With a lot of health conditions, they can actually use AI and robotics and intelligent systems to solve problem for them. And this is happening. I mean, there are a lot of use cases I've seen myself. And then for sure, innovation and creativity, that's a area where people, when they struggle, at least the starting point can they can arrive on, take inspiration from AI, and then they can take it over from there. Things like those can actually happen, especially like if you practically look. A lot of people might be creating content using ChatGPT because probably writing as a creative skill is a challenge for 80% of the population. Not everybody can really write and think. If they think, they might not convert into a very crisp idea or way to communicate it to other people. And I think that's great if somebody has a very good idea. I mean, they have a mechanism of thinking through and they're not able to communicate it. AI can do that bit for them using GPT's kind of solution. I mean, it's a big win for humanity. We rather than we think about pleasurism or any other issue, if we can actually think it in creative way and make mechanisms like those, this can be used in a very positive way. As I said, definitely same challenges. Socioeconomic, because everything is related some way or other economically as well as the well-being aspect of ethics. So job displacement is one area we have to look for. How do we solve for this problem? So as I said, humans can tax AI. And in white papers that we write, if you can tell this is where a subject matter expert or maybe somebody who's doing a monotonous job is replaced with AI. These are the new roles and job description we can create for these people. As expert of industries where you belong, if you can do that bit, the job displacement can actually become another mechanism of prompt engineers coming out of some jobs where they make these systems better. And because this is an evolving process and this is a constant process of training these systems. AI will not become perfect because there will be new challenges that will come and a prompt engineer has to prompt it who would be a subject matter expert, probably with lower seniority, doing monotonous job. But again, those will be their future jobs. There will be inequality, we assume, because certain jobs will go away first. There'll be a disparity in terms of economic background that people have. Some of those challenges have to be addressed, which we'll see in coming years how people are planning for that. But I feel practically I see in malls in India where there is a button for the boom barrier to go up, yet somebody would be standing next to that boom barrier pressing that. So there is a human element to some of these things where we don't really let go the people when the technology comes in. So probably those kind of transitions would actually help us keep this gap smaller. And probably while you write for columns, while you talk to people and you really make them aware of it, these are the smaller areas, potential challenges that you can talk about and give them these ideas from your perspective. This is a better way to keep this gap smaller and things like those. Privacy is a huge concern. Samsung's one of the R&D guy in the US uploaded all the document thinking that he will actually get a very crisp document out of ChatGPT. And then Samsung had to actually cut down access of ChatGPT within the organization because competitors were actually having information of the patents which were supposed to go out. So privacy is a problem. And that's where I said hosted, which is on your own servers. You take these models, then you train them. So you have to put a process around it and take care of privacy, which is doable. I mean, like privacy is a concern generally, but with AI, if it is actually misused, it can become a bigger problem because your personality information, your persona, it's not just identity on the level of passport or something. Your voice fabric, your videos, everything can actually get compromised and can be a big challenge for someone. Ethical thing we discussed, transparency and explainability we discussed. So how do we do this? How do we solve for it? I already spoke about it. In your domains, if you can write policy documents, you can work with like some of the regulation bodies, write white papers, contribute, get students and interns to think about it. We have to reskill ourselves always. We have to upskill ourselves always. So this one of the ways is like doing these kind of sessions. And then we do more of these and it helps the whole thing to really be ready for the transition basically. And I said the job market, the new job descriptions have to be defined. So people like us, we'll have to sit through and then figure out like what would be those. And last but definitely, like we have to figure out forums, meetups, places where we can go, where we think we have enough of ammunition to talk about this now. We go to the right forums, we take the spot in meetups and then we start talking about it. And we tell people how they can be responsible, how they can actually build inclusive solutions. That's a mechanism we can think about. So that's it. we are at end of it. I've gone over time, but like all of you are a great audience. Nobody was stopping me on that. Any questions, please?
Thank you, Mr. Sridhar. You can stop sharing your screen, and we are open to the questions. So, anyone. I can see Mr. Rakesh Vajpayee has raised his hand. So, Mr. Vajpayee, kindly ask your question.
Hi, firstly, I just want to thank you for such a wonderful session. And, I think I have learned so much from this session. While you were, speaking, I was kind of making a lot of mental notes. One question which I have is, basically with all this onset of social media, etc., one could see that, the masses, you are seeing a dumbification of masses. People are kind of not critically thinking, and they are kind of, becoming more like herds. This is a value judgment. It may be wrong, and I have no data to say this, but I kind of find this as a trend. Now with AI coming in, would people become even more lazy and, not do the critical thinking and let the AI do that part? And therefore the risk of, the society becoming even more dumb, and therefore, getting kind of carried away in the herd mentality. Do you see that as a risk?
So, so thanks for your feedback. Like this was useful for you first. To your question, I have my observations on this. I mean, like when I look at social media, see, practically most of the people, they are consumers. They don't create content. I'm just talking about general human behavior right now. So how many people would have created these kind of groups and they would be doing intellectual discussion, practically thinking about it? I mean, an average person, I believe, they will discuss things which might not really change anything, or they, even if they know how to do it, they have to take action. So I from my experience, what I've seen is in different countries, not just India, I'm not talking about Indian perspective, but like though America is a great nation, the way they position themselves, they are a superpower. But I find 70 to 80% people actually dumb there, don't have qualifications as good as, they would not have gone through grind, I would say, not education degree, but they would not even have gone through the grind that an average person in India would go through. The kind of sharpness, street smartness we have in our folks is pretty high. But again, calculators have made a problem that my generation people don't really remember all the tables that will. Their mental ability, mental math, basic algebra is poor. Generally, I see that. And to blame, I can always blame calculator. But again, it was a choice that I made while I progress, that I have to do certain more things and keep getting better at it. And while I feel as an intellectual, if I feel that the gap is there, that self-awareness is there, I'll make sure my kids really don't make that mistake. I think it's a mechanism, it's a system, it's a function where people around us, if we can create that impact, we should just solve for that. We cannot solve for this problem because by design, I believe humans are lazy. Just to keep it a civil system, that we are not barbaric and we're not killing each other for shining coconuts. There is this society right now. I feel we have to still evolve as humans a lot. There is more to the pursuit. Good thing people are talking about some of those things now, but again, as you highlighted it, that's true. People, we are seeing it today. It was always true. That was the scenario, and people would say, let's go march today. Everybody will join because everybody has been invited to a march, be it a peaceful march or a violent march. Nobody will care about it. They'll just show up. That was the case earlier, but we never saw that reportage. Today, the reportage is very transparent. Anything, any nonsense happens, and we get to see it. Any good thing happens, it amplifies. So the bit is, how do we influence people around us to do right things? How do we influence people around us? And it doesn't matter, because when you're doing good things, a lot of people would be naysayers. They'll just say, no, don't do it. Why are you wasting time? Nothing will change. But again, even if you can impact 10 people around you, that will be the only way to solve. Even if the AI comes into the picture, when people want to become lazy, I see they'll not write documents. I see a lot of things. They'll not need to write programs. But again, this is very good on the other side of it, because we have virtually created mechanism to keep ourselves busy. As society, as humans, is that our ultimate goal from consciousness perspective? If that's our ultimate goal, then I don't think we are on the right track. If there is an ultimate goal which is different from what we are doing, the materialistic life we are living, people, richest of the richest people have sit with on tables, on yachts, places for dinners and lunches, they are not getting good sleep. they are on melatonin, they are taking medicines, they're not satisfied, they're very depressed. Many of them, most of them, I would say. So the materialist life that we are, the life that we are and the way we are into this process, I personally feel this problem is a bigger problem than the dumbness. And I feel like let people be dumb generally because at least they're not doing wrong things. They're following herd mentality, and you can still get all the herd into right direction easily rather than like people super intelligent. My problem is neural links. If every dumb guy or a monkey gets a neural link chip on their head, and they can pick up guns and they can think of all malicious ideas and create a society which is very dangerous, that's going to be a problem. I mean, the zombie was a poor concept earlier, but Neuralink, I'm seeing in this lifetime, if we have to see that, that will be the real horror of life. So those are the real challenges. But yes, people will continue to act dumb. There will be some people who will actually act really very wise. And it's not that I'm saying that with entitlement, but I'm saying I'm learning. We all are learning, and people have to do that constantly. And we have to push people around us to do that. That's the only solution. But people will be lazy. It's good. That's how it is going to be. I hope I answered it. But yeah, people are like that. Technology will not change much of that human behavior directly, sir.
Thank you. Thank you so much.
Thank you. Sarita ma'am, I'll come back to you. I see you have raised a hand. But Mr. Sridhar, I had a point here. It's not exactly a question, but something which I had experienced and in the same context. This is regarding, in the medical field, use of AI. And what Rakesh ji said, or the question that he asked or he commented, something similar, something in the same context. IBM Watson was being used for a diagnosis and not exactly cure, but to suggest the treatment protocol for cancer. And Manipal Hospital in India, Manipal Hospital, Bangalore, was the agent through which it was being done. Manipal Hospital, Bangalore. The format was like this. The patient or whoever is the next of kin of the patient gives all the inputs supplied to the agent there at IBM Watson, all the reports, the PET CT scan, etc., blood reports, and then it views it and it gives an output that, of course, was not a sacrosanct or something which could replace an oncologist's protocol or his suggestion or line of treatment, but it was something which could be taken as a second opinion, But then what has happened was, in due course, I don't know, probably the doctors or the oncologists found that it was not meeting the criteria, and this was withdrawn. So IBM Watson being used at Manipal Hospital, Bangalore. In fact, it was free for IBM employees. If any of the relatives or IBM employees had this requirement, they could use it free of cost. But all that was withdrawn because it was not found to be to the satisfactory level, in the sense that probably the accuracy was not to the desired level. And in any case, it was assumed that it will not replace an oncologist or it will not replace a doctor. So to that extent, why I made this comment is, whatever be the case, a human being cannot be replaced. That is what my understanding is, in with whatever profession that we think. I mean, when it comes to the highest level of analysis or kind of making recommendation. So anyway, if you would like to comment.
I have a point to make there. So basically, if you practically compare this to autonomous vehicle, there's different kind of impact we run into. But typically, if you look at it, there was one point of time a decade ago where nobody would assume that a car can drive in traffic point to point without a human being driving it, a driverless car. And if I ask you which car do you have, if you say Maruti, and if you say my car broke, and if I come to inference saying that cars are having issue, but it was Maruti which had issue. What I'm trying to get to is IBM might not have issue, but probably the people and team which implemented it, the way data was used, because there are so many factors. I mean, it's like we look at only the ISRO failing when Chandrayaan doesn't land. But when you fix that particular component and you relaunch and you do it one more time, you would get it right. But the point is, we will see, unfortunately, we will see scenarios in future where humans will be replaced, because there is a big lobby working. Everything is a lobby, is what I see from my experience working in certain positions. While we talk to certain people, we realize after a point there is a set of people who are actually decision makers, because there is a lot of wealth that flows. Why it gets to be part of system? If genuinely people are good and they look at impact, they might decide not to do certain things. But like, because there is wealth flowing, a lot of people make these decisions, unfortunately. So I believe we will see that happening, unfortunately. But if humans, if our average human being, I'm not talking from IQ perspective, IQ, EQ, consciousness, everything put together, is taken, a cohort of average people is taken, definitely AI will for sure perform better than them. That's for sure. So I cannot compare an AI chatbot of Sadhguru giving real enlightenment to somebody who actually Sadhguru would give it to. I mean, that's the kind of difference practically if I have to talk about it. So there are things like these that will actually cannot replace people with. But again, process, physical decision making, certain things around that might eventually become one of those factors where people will be replaced by AI. I think there are other people who want to ask questions actually.
Yes. Thank you. So, Dr. Sarita, I see there are 3 hands, so I'll start with Dr. Sarita. Ma'am, kindly unmute yourself.
So I'm unmuted. I just have a few things to talk about, to comment. Number one, you gave example about Neuralink, and if this is in gun or whatever bad things involved with the Neuralink. But the thing about, we have cloned organs. So there is an ethics part, which every country and every company ultimately has to control. So the Neuralink, purpose of Neuralink is the first case where Neuralink is implanted in human being is he used his brain to move the mouse of computer.
No doubt about it.
Yeah. So the technology is going to grow. Similarly, the ethics part will come and it will grow. It's the same thing like in every hospital, what previous generation did is much different than what we do, and it will be much different what next generation does. So ethics part, not necessarily parallelly, but it still grows with this. Also, the evidence is already there that because of Google use, children, the critical thinking of part of the children is not that great as previous generation, like our time or even before that. Now, study have already shown that if you take the education part, this is a very good study. Education part, whether you do video learning, class learning, or just read something and learn. When you read something and learn, you start thinking, your brain works there. But if it is very complex, if you show video, it will be easier to learn or faster to learn. So that is like a balance you have to make in terms of learning part. Anyone thinks that AI is not going to replace human, they are like a little beyond. It is going to happen. AI is going to replace human brain. Yesterday, I saw one report where computer worked for 1 second of 3 trillion thinking, which is close to human mind. So now next will be surpassing human mind. So yes, this is going to be, and the third, which you said, someone is controlling, which is very true. Same as Vanguard and couple of people who control the world, the wealth control the world, they will control the AI too. That's all.
True.
This is based on some real information.
Absolutely, these are insights. Absolutely, these are true insights.
Good discussion.
Totally
Thank you.
Agree to that.
Thank you. So we have next Mr. Avdesh Krishna and Kashvi. I'll come to you after that. So Mr. Avdesh Krishna, kindly unmute yourself.
So thank you very much. I think it was brilliant. Such a vast subject, so lucidly concluded and covered in such a quick time. So thank you. I can't say I've understood everything, so I'll have to go back and read your PDF and follow again through this video again. But having said that, one of the questions I have is, many times we are talking of making a plan to travel somewhere, and then I go and I log into my mail, and then I have a lot of those make my trip and those kind of companies throwing in mails directly. I'm talking of receiving mail saying, here is an offer for this air ticket or something. So is it true that when we are not even logged in, our computers and our mobile phones are listening to what we are saying and doing? I'm not very tech savvy, so I don't use Alexa, and so I don't know about that. And if yes, then what are some of the precautions that you suggest we should take to not get swindled with these kind of things?
So the precaution is go back to basic phones. I'll start with that because uh, even though Apple says that there is a orange light, green light illumination that starts the moment cameras are used or mics are being used, I believe Samsung and Apple still are better devices to use because they still have to take care of the European standards. If there is no government body behind somebody after these kind of larger companies, they'll still follow ethics. I personally feel that from my research. But if you take certain cheaper phones and devices, for sure there is a bigger risk. Your MI TVs are big risk. Your cheaper devices are big risk because they don't care about the storage. There are larger data farms available for them to store all the volume of data that is available. For the ads that follow you, that will go away very soon because third-party cookies are going away, which means the data which is captured in a browser when you see something, that email ID, who this person was, that information is transferred when you open the other website. This is Gmail. And Gmail has an advertising platform which identifies you and what you saw on the other website. And then this information is passed to the advertiser. All automatically happens. And then they show you that. This is going away because Europe has pushed for pretty hard bit on GDPR plus the ethics part of it, which now has to be implemented across because all the advertising industry wants to keep it as only first party cookies, which has nothing to do with AI. But again, I feel there will be other ways to circumvent this. We'll still be at risk. Are we being heard constantly? Yes, we are being heard constantly. There are evidence, there are cases done in the US where people have figured out this. And when you talk about certain things, when you share certain things in WhatsApp, you'll start seeing those ads. When you talk about certain things on your phone call, especially WhatsApp phone call, it's getting heard, it's getting recorded, it's getting processed, and now it is part of the advertising ecosystem. That's why they paid 18 billion for that product 10 years ago, because now it is used for advertising while Facebook is getting dead. So we are data points. We will have these issues. The best thing is one, maybe use two SIM cards, different phone numbers, keep certain information available, use two email IDs. There are these mechanisms. But again, there's no end to the paranoid situation that we will run into eventually after we do this. So the best thing is like you limit information that you share, keep your digital identity little limited, have mechanism of more offline storages, things like those. But the way we are right now living in a world for a backup for this and that, everything gets to the cloud. And while that's happening, it's really very difficult to control. I mean, there are mechanics, but again, these are not for everyone on day-to-day basis. Those mechanics are a little expensive for encryption using like browsers like Tor, and some of those are new mechanics, but still there will be ways to circumvent that, like all these advertising companies will do. So there's no real answer, but again, people will say use firewall, this and that. That really doesn't help much practically. I know I might have disappointed you, but again, we are living in that. The real risk I see is for the next generation and the kids. And it's going to be really difficult for them. I cannot really imagine what we are going to see in future.
Thank you. I have more questions, but I'll come back if I get a chance again. But I think we should go to the next person now.
Thank you, Avdeshji, and thank you, Mr. Sridhar. Kashvi, over to you. Kindly unmute yourself.
Am I audible?
Yes, you are.
Yes.
First of all, sir, it was an amazing session, and I'm going to take back a lot from this. Also, I'm really honored to be a part of this meeting because I am technically an amateur between all you professionals. I would like to go over the point Sarah ma'am mentioned. I feel like it's not people versus AI, like the systems. It's more of a intersecting Venn diagram where they both complement each other, because in the end, there's a lot of data discrepancy we see even online. So if you, in the end, if you have to sort out the chaos, a human will have to intervene in the end. I mean, that's just what I believe.
So, to be honest, this all looks, first of all, thanks a lot for the feedback. Highly appreciate for staying back for this long. I know like we have gone 2 hours into the session now. And for the question too. My take on that is we believe that's a wishful thinking, to be honest. And I felt that way when I was in Facebook. This is just a website, why people, there is so much of fuss around it. It's just a website because I made a social network myself with somebody offered to fund. They want to start it in Dubai in 2008-9, and then I joined Facebook. And then when I was leaving, my partner, my wife, basically was at Facebook. She was in HR department. She continued over a decade working with Facebook, and I moved on to the next opportunities as they arrived. People reached out to me, and I took that. I did not stay back because I believe that ways, and my opinion has not changed while I move and see technology and meet people. That this is beyond our control. This is happening. That landslide is absolutely happening. Even if we have that visual thinking that humans are needed, we will be needed in our lifetime. If we don't get to see it, we are lucky enough. But I personally believe things would move very fast. If there is no war, we will run into situations like a World War III. We'll run into situations where we'll see a lot of systems, many of our systems by next 20 and next 2 decades, basically next 20 years, will be all AI-driven, less human intervention kind of systems. That's the system I'm seeing right now, especially developed nations. Recession is coming. That's a good sign. Technology will slow down. I mean, I believe these are the multiple connected factors where GDPs go slow, certain things hit recession, they hit depression. I mean, humans, if we don't go into that mechanism, the technology will become too fast and there is risk. But that's why I'm saying in our lifetime, if we don't get to see it, we are lucky. I mean, like we saw pandemic. So after seeing pandemic now, the opinions would have changed in life, like how our outlook would change. So that's why I'm saying this will happen. Humans, when you are actually a decision maker of a large organization, what you will clearly see yourself is places where there's human error and margin of error, and you build a system which is completely automated or AI-driven intelligence system, which is not producing those errors. You will love to replace human with that system, and you feel like, oh, now this is doing perfect job. And 10 times out of that 10 times, my assistant is actually making mistakes, say 6 times or 7 times or 8 times or 9 times. But the system 10 times when I ran it, all 10 times, 10 out of 10, it gave me right answer. So let me replace it. This is the right time. That will happen for a lot of people. We'll see it a little late in India. And with the population and the kind of governance system we have, policies, it will come a little slowly to India. But I believe in next 40, 50 years, there will be different kind of tasks we all will be doing rather than day jobs. That will change for sure. I mean, like imagine people who went to factories, they never imagined they will have desk jobs and they'll be doing IT work and we'll be having these kind of calls and systems. Like back in 2002, 2003, I never imagined we'll have such a nice Google Meet call where we used to struggle back then on GTalk installed on a Windows machine where dial-up would work. So I'm saying it's happening. We have to accept, and I'm saying sooner you bring acceptance, your brain will be ready to figure out mechanism because you definitely are above average where you have to figure out and you have to help people who are into average segment to be ready for it. How do we do that? What they will do? I think if we start thinking about it, I'm not creating, there is no conspiracy theory here, but I'm saying it all by experience and I'm not creating a overwhelming situation where we feel that it'll happen. But I see it's happening. I used to be on the other side of it where I was very optimistic. No, we are very relevant. Humans are needed. But this is happening. This is my gut feeling. This is my read of what's happening right now.
Yeah,
Yes, sir.
so
Thank you.
maybe
Thank you,
Sridharji, I think this is Anurag. I wanted to ask you one question. I think being a
Yes,
career
please.
IT professional, really appreciate what you packed in 2 hours. And I think given your deep knowledge, one question I have, one of the fundamental for this group had been that impart knowledge to the next generation that how they should actually carry. I know it's very difficult. I'm in the IT and I see that change. very difficult to project that what is going to happen. But what is the message you'll give to the students, who are like teenagers looking to build career, and for them to be relevant for next 20 years? How they should build their career? What is that they should be working on for next 15, 20 years so that they remain relevant in the world of AI and not get replaced by an AI?
See, this depends. Actually, I go to a lot of colleges as part of my mentoring activity from different Atal incubation centers, in which Stanford brings a very different quality of cohort. That's why I'm saying depends. When I go to a tier one city top college to average college, which is little on outskirts of city, which would be a state entrance exam kind of institute, I think the rigor itself is very different. And when you, if I want to make a recommendation to both the cohorts, it will be a little different, practically speaking. Because I'm not judging people by their college or their scores, but I feel the fire, the ambition, where they want to be, some of that is set in that particular trajectory itself. So if I have to talk about how do you increase your knowledge, it's a behavioral thing. I personally feel it gets to the next level. When they say you are average sum of like 5 people who you spend time with. I personally believe that because if 4 people around me or 5 people around me are really enthusiastic about education, learning, they are sharing that kind of content, my brain will be pushed. I mean, a simple example, I have to write a Pravesh exam of Sanskrit tomorrow. And there are 4 people in my family who have reached to the COVID level of Sanskrit. Though I have nothing to do with Sanskrit ideally right now at this point of time, maybe in future, 10 years later, I would want to do that. That's somewhere back of my mind. And now I picked it up because there is this peer pressure that has been created. And they're not saying do it, but I feel like there's opportunity I am missing, and I'm involving myself. I'm saying the advice for them is go meet people. Culturally, we are bad at meetups. We are very introvert. There's culturally one mistake that we are making because US has crossed that cycle. Europe has crossed that cycle of that independent mindset, where people who achieve first, they think too high of themselves. So we have to be a little humble. We have to go and reach out, seek help. We have to learn from others. And people who are seekers will always have to keep their heads down and learn. I think that is the biggest problem. And I would tell them, go meet people, learn, travel as much as possible. Within your purview, rather than buying 1,000 rupees pizza, use 1,000 rupees, travel, meet people, learn. So it's all from their experiences. When you capture as much as possible, you will come across people's common wisdom. And that will actually give you the right direction because you will know your strength. AI, technology, everything is just a means, and you still need real people, real mentors to guide you to set you onto that trajectory. So to get to that trajectory, you need right set of people around you. And I think institutes only help you meeting right people. It's not about the professors who are teaching you in the content. It's about the professor's mindset and the students who are studying along their mindset. I think that's the game changer. And that's my recommendation. Go meet people, talk to them, learn. I mean, that's where everything will start happening. All the magic will happen.
Thank you. Thank you so much,
Thank you,
Mr. Sridhar.
beautiful answer. Thank you.
I can see Avdesh ji had raised his hand. Avdesh ji, do you still have a question?
Actually, Anurag asked my question. Thank you, Anurag.
Okay.
That's why I removed my hand. Thank you.
Okay. I think we are well past 2 hours, and yeah, Gopal ji, I can see.
So I don't have any questions. So I just wanted to say that Sridhar, you conducted the session really well. This was an amazing session, and in fact, we covered everything that we had discussed, which is really nice. And I see a few students also joining this call, so I'm sure they also, took a lot of leaf out of your insights and experience. So amazing session. Hats off to you.
Excellent. And
my pleasure.
Yes,
my pleasure. Thanks a lot for this opportunity.
Absolutely.
I have a question to all of you. How can I become part of this group?
We will add you to this group.
We
Yeah,
will
because
add you to this.
for sure there are a lot of learned folks here, and then definitely there will be opportunities to learn from each other. I would love to be part of this community.
Yeah, and it's an eclectic group. So it's a diverse group.
Absolutely. I mean, that's the real value.
And in fact, Sridhar, this was a silver jubilee session. So
Oh, wow.
Yes.
From that
Honored,
perspective,
actually.
also,
Thanks.
this was an amazing way
Absolutely.
to actually celebrate this silver jubilee.
Okay.
Thanks a
And
lot for inviting me today.
Before we close, Mr. Sridhar, one more point I wanted to highlight here, and I've not seen many people talking about it when they talk about AI, and it was there in your history slide. The point that I wanted to highlight is AI has been there, and as you mentioned, it has been there for last 50, 60 years or so. But why this sudden change or a sudden spike in the activities? It's primarily because the computing power has enhanced. The processing power, the storage power, the memory is never. Moore's law, of course, comes into play everywhere. But in this case, AI has primarily been benefited because of the advancement in the hardware technology. So thank you for bringing that point, which I don't see many people highlighting it. So great session anyway. Thank you.
Because you just said, I'll just add one more thing quickly. Quantum computing is coming. That is a real big problem and threat for
Yes.
cybersecurity. And the compute that we have right now, I mean, it's just going to go another level. That's why my gut feeling is very different about people being replaced by intelligent systems. Apple in this version of update has replaced algorithm and software to encounter cracking through quantum, which means like the SHA-256 algorithm, which is very difficult to crack, has been actually cracked by one of the scientists using quantum computing. So if that comes into place, how the complex things will become very easy for people to solve it. So we'll see how it really goes to the next level. I think Dr. Raj has
Dr.
a
Jha,
question.
yes.
Yes, sir. Jha, sorry. Yes, sir. Sir, you're on mute,
Sir,
sir.
you are muted. Yeah. Dr. Jha, you are muted, sir. You have to unmute yourself. No, not yet. Yeah. Sir, for some reason we can't hear you,
We can
Dr.
hear
Jha.
you. Yeah, we can. Jha is saying, Dr. Jha, I cannot replace your Pankti. Probably you should write it. But he's saying that he's much more wiser than when he started this session. He feels so obliged and humble. But then he also has an anecdote. The question is that, can a surgeon will be replaced by an AI in future?
No, sir. I would say I'll put it like this: a surgeon will become eternal with AI. So the wise senior doctors, their intelligence will actually guide people forever. That's how you have to look at it. So the quality of doctors that I have seen in my limited lifetime, yet it has dropped from the way senior doctors used to do that. The way they would prognose, there is a human element. Now, when I've spent 5 years ago some time in emergency rooms for certain relatives, I've seen the junior doctors. Now they call themselves consultants, and they're still figuring it out. The way they approach things, the way they do, the generation is very different, and it'll become very different even in coming days. But I feel the eternity and that knowledge of doctors, how to do certain things, certain questions, we'll definitely have a dumber generation that as we know it is, but there'll be only few of them which will always be able to think right. And you would have seen it, like the number of senior doctors who would advise earlier, from that number, what it was, it would have dropped now. So I believe there will be eternity for certain real intelligent subject matter experts. Their knowledge will be useful for a lot of people, and these AI systems will guide them ideally.
So I don't know you have seen the news or not. In International Space Station, the first surgery, like a simulation of surgery, was done from NASA. So the surgeon is sitting in NASA office on Earth and perform that simulation on International Space Station. So yes, the hand of surgeon, the amount of involvement of hands of surgeon is going to go.
So I did not read this story specifically, but I have seen videos of equipments where the robotic arms are performing surgeries and it's coming into play. Absolutely. So, but I see that's coming for sure. But again, I feel these are the critical verticals for human society, ideally, especially healthcare, where if doctors are and that knowledge, I mean, because I feel there is a reason why a person, once they feel comforted by meeting a doctor, I've read these paper where placebo effect of consulting doctor itself really heals patient. I've read about those topics as well, and I feel if you can create that persona and somebody can get that level of comfort after unfortunately passing away of a doctor, I mean, that's a good beacon at least to guide people into right direction of how they would have thought of. Because I said somewhere during my discussion that personas can be created, knowledge can be captured in a certain way. So ideally, we have to use, I mean, this is where our education forums and writing white paper, writing policies, figuring out ways to be part of those sessions where we can actually make policies. We'll have to do that to get it all into the right direction.
Okay.
Sir, I think
Thank you.
Dr.
Yeah,
has to.
Doc-
Yeah, he's.
yeah, I think we'll take this as as the last question because we are more than 2 hours plus or so. Dr. Jha, again, Anurag will have to do that relay.
So Dr. Jha is saying that it's already that level is already achieved where minds of the doctors are working and robotic hands are performing surgery. He'll be very interested to see what will happen in next 10 years if he continue practicing medicine. Thank you so much, Sridharji. I think thank you so much, everyone.
So Anurag, on the lighter side, just curious to know what kind of AI you have that you can only hear Dr. Jha.
Maybe I'm in both Dr. Jha and I are in US, and maybe that's the reason I'm able to
latency.
see.
Absolutely,
It could be the latency thing.
Okay.
And this restores my faith in humanity. Technology.
Yes. Very well said. So thank you so much, Mr. Sridhar, and truly it was a silver jubilee session, one of the longest sessions that we had, and I'm sure if we had time, it would have continued for much more time. So thanks once
Thanks
again.
everyone for your time. Thanks a lot for inviting me. Thank you.
And welcome to the group. Welcome to the group, Sridhar.
Thanks a lot.
Thank you, Sridharji. बहुत अच्छा था.
Thanks,
You
Sridhar.
understood
Thanks,
Hindi a
Sridhar.
little bit.
Thank you.
Thanks everyone.
That's
Have a good day. Have a good night.
Thanks.
Bye.
Have a nice
You too.
weekend. Thanks.
Thank you.
Bye.